This is Mr. Hassan's Maths channel. I'm now answering question number 17 from the June 2022 IGCSE Cambridge paper 20580. And this is a question about trigonometry, and part A is about the sketching of the sine curve y equals sine x between 0 and 360 degrees. So they gave us a little pair of axes here. For a sketch, it's not going to be something elaborate. But what I want to do is split it into 4 parts. So what I'm going to do is I'm going to use a ruler here just to make sure that the parts are equal. Now, the ruler is maybe not the same scale as what you guys might have. All right. I'm just going to use what I have. I can change this so that it's easier for me. Right. I'm not sure what your scale is, but I'm just going to use this. So there's 6 here. That's halfway. That's going to represent, so it's going from 0 to 12. So I want to put it into parts. So you've got half. So that's going to be 180 degrees. That's going to be 90 degrees. And that's going to be 270 degrees. Split it into kind of equidistant areas so I can make sure that I try to do it as accurate as I can. So this is 90. This is 180. This is 270. And we have to draw the graph. Now, the sine curve has this type of shape. It starts from 0, 0. It reaches its maximum value of 1 at 90 degrees. It goes back to 0 at 180. And it goes to its minimum value of -1 at 270 degrees. And then back to 0 at 360. So it's that type of shape. That's how the sine curve looks. That's how we have to try to draw it as best as we can. All right, so we have curves up like this, goes through 180, and it curves back up like this, goes to 360. That's not that good, but it's not that easy to do on this stuff, but something like that, a bit more rounded. It shouldn't go like this, like from there. It should be kind of more rounded like that. Okay, so there we have the sine curve as best as I could do it on this app here. Okay, trying to avoid these double kind of lines. All right, so it says just make a sketch of the graph. That should be sufficient for you to get the marks for that question. All right, so that's what the sine curve looks like. Now, if you forget what the sine curve looks like, then take your calculator, make sure it's in degree mode, and then you can say, okay, the sine of 0 is 0. Okay, and you can say the sine of 90 degrees is 1. And you can go to 180, and you'll see that gives you 0 again. And 270 gives you -1, and so on. All right, so you can kind of like, you can kind of like figure out, you know, where to go by using your calculator. If you forget, but you shouldn't really forget how it looks. This is what the sine curve looks, something like that. Okay, it's not perfectly drawn, but it's as good as I can do. Now, for part B, it says solve the equation 3 sine x plus 1 equals 0 for values of x between 0 and 360 degrees. So to solve an equation like this, the first thing you need to do is make sine x the subject of this equation. You need to make the sine x the subject. So what I've got to subtract 1 from both sides. Just a bit more tiny. So I'm going to subtract 1 from both sides. So I have 3 sine x equals -1. Take 1 away from both sides, and then divide by 3. So sine x equals -1/3. Now, for us to solve this, we're going to find all the solutions between 0 and 360 degrees. Now, the first solution is always found by using your calculator. So you have inverse sine of -1/3. Okay, now that gives us an answer. So if you take our calculator, make sure we're in degree mode, which we are. So you have shift sine of -1/3. Okay, so that is the calculator answer. It's called the principal solution. And you can see you get negative 19.471. Negative 19.471. Okay, so now that answer is actually not within our range. It's not within our range. 19.471 is somewhere over here. Negative 19.471, sorry, I'm talking about. Negative 19.471 is somewhere over here. It's negative, it angles on the negative side. Negative 19.471, somewhere over here. So the curve, if you were to continue it, okay, this would give you a solution somewhere down here. Okay, it will give you a solution somewhere down there. So what we have to understand is this is not one of our solutions. Okay, this is not one of our solutions. But what do? Do we just say, okay, there's nowhere where the sine curve hits minus 1/3? Well, there is. We can see that if I drew the line y equals minus 1/3, it's going to hit the sine curve in our part where we want it to in two places. There are two places where the sine curve hits minus 1/3. The line y equals minus 1/3. There's two places between 0 and 360 where it hits them. And we've got to find those two places. Okay. Now, the only thing we're going to get from the calculator is this angle here. It won't tell us anything else. The calculator will not tell us anything else apart from this angle over here. That's the only thing it's going to tell us. It won't tell us what these angles are. Okay, it only gives us the angle closest to 0. We have to use our understanding of the sine curve to find these other two values. And it's pretty simple. Okay, for the sine curve, it's pretty simple. Always, to find the other angle for the sine curve, we do 180 minus the angle that the calculator gave us. So it's 180 minus 19.471, which ends up being 180 plus 19.471. And you can understand how that is from here, because this, between here and here, that distance is 19.471. Between here and here, the distance is also 19.471. Same, because it's symmetrical. The sine curve has this property of symmetry. So this is also 19.471. So you can understand how this is 180 plus 19.471. But without even drawing the curve, we can understand from this understanding that to find the other value for the sine, this is for the sine curve, to find, you get the principal solution by the calculator, and 180 minus that will give you the other solution. In this case, 180 minus that is going to be 180 plus 19.471. So we take our answer and we do 180 minus the answer, and it gives us 199.471. So that's 199.471. So that's one of our answers, which we're going to round in the end when we write it there. Now we got to find this other angle over here. So we now know that this angle here is 199.471. How do we find this angle? Now, there's a few ways we can do it, but probably the simplest way is to understand that the sine curve repeats itself every 360 degrees. So this part where the curve is going up like this, and this curve, this part where it's repeating that same pattern going back up again like this, they're separated by a distance of 360 degrees. So those points are separated by 360 degrees. Okay, so you can think of this angle here being minus 19.471 added to 360. Or you can think about it as this distance is the same as this distance because of symmetry. Okay, it's not drawn so well, so it doesn't look like it. But this distance is the same as this distance because they're symmetrical. So if that distance is 19.471, so is this distance, which is basically 19.471 less than 360. So you can think of it as 360 minus 19.471. Okay, so that's how we end up with the next answer. So if we go to the calculator, let's go back to what we had before, which is this. If I add 360 to this, I'm going to get my answer, which is 340.528. So that's going to give me 340.528. Let's make sure I've written that down correctly. Okay, it goes on like this. So now in the end, we're going to write our answers to 1 decimal place. Is that what they told us to do? Didn't tell us what to do. Nope. So that means we just write it to 1 decimal place because that's otherwise specified. So we don't write this answer down, even though it was a principal solution because it's not in our range. We write down the answer as 199.5 degrees and the other answer as 340.5 degrees. And those are our solutions. Okay, those are the solutions to this question. Now, if you want to just check to see, in case in the exam, if you're correct, okay, now these are rounded answers, okay, so it's not going to give us the exact answer that we're looking for, but we should get something close to 1/3. So if I press sine of 199, sine of 199.5, it should be something close to 1/3, or sorry, negative 1/3, negative 1/3. Okay, so we can see that's close to negative 1/3. This is minus 0.33. I told you it's not going to be exact because we've got this rounding going on. And we can write this as 340.5, and that should be close to negative 1/3 as well. And you can see again, it gives you a very similar answer, negative 0.333. So it's close to the right answer because it's rounded. That's the reason why it's not exactly the right answer. But that's how we can check to just see we've got the right kind of on the right tracks. Okay, so that's how you deal with these type of sine curve questions where you end up with a negative value here when you're finding the ratio, and then that will lead you to a negative angle here, which you don't include in your answer if the range is between 0 and 360. You find the first angle by doing 180 minus the angle that the calculator gave us, and the next angle you do by adding 360 to it. And you can think of all in terms of symmetry if you want to as well, and that's fine. So that concludes question number 17 from June 2022, IGCSE Cambridge Paper 2 Extended. Other questions from this particular paper can be found in the playlist that will be in this region here at the end of the video. And the playlist that will show over here, if you click on it, will take you to my questions dealing with trigonometry, trig equations and graphs. And the general playlist for trigonometry we found over here. You can also watch the video that will appear in this region that will help you to navigate through my channel to help you with your IGCSE revision. Thank you for watching and see you soon.